At first glance, this looks very similar to the last technique that we looked at. Express cos to the power 5 of a sine to the power 5 of a in terms of cos a, cos 2a, cos 3a, or sine a, sine 2a, sine 3a. In fact, it requires a very different technique. Apply the wrong technique and you can end up wasting quite a lot of time. Before we can go straight into it, we need one or two preliminary results. We know that z is e to the I theta, which is cos theta plus I sine theta. We also know that 1 over z, well, 1 over e to the I theta is e to the minus I theta, and that is cos of minus theta, which is the same as cos of theta, plus I sine of minus theta is minus sine theta. From that, we can easily pick out that z plus 1 over z is equal to 2 cos theta, and that z minus 1 over z, if we subtract the two equations, the cosines disappear and I'm left with 2I sine theta. We get exactly similar results if we deal with z to the n and 1 over z to the n. And I've written those down just up here for you. Same thing, z to the n, e to the in theta, cos plus sine. So it's exactly the same as over there, but with an n in. We will need both sides of this. Okay, let's move on and have a look at this. Express cos to the power 4 theta in terms of cos theta, cos 2 theta, cos 3 theta, etc. We will need for this the two results from above, that z plus 1 over z is 2 cos theta, and we shall also need that z to the n plus 1 over z to the n is 2 cos n theta. Right, we want to start with cos to the power 4 theta. So taking the first of these two results, I can write that 2 cos theta to the power 4 is z plus 1 over z to the power 4. The left-hand side, 2 to the 4 is 16. And the other side is Pascal's triangle 1, 4, 6, 4, 1. Z to the 4 plus 4 z cubed 1 over z plus 6 z squared 1 over z squared plus 4 z 1 over z cubed plus 1 over z to the 4. Well, looking at the first and the last, that is z to the 4 plus 1 over z to the 4. Why do I like that? Because z to the 4 plus 1 over z to the 4 is 2 cos 4 theta. Well, what happens here? Z cubed over z is z squared, and z over z cubed is 1 over z squared. So if I take these two, I get 4z squared plus 4 over z squared plus 4 times z squared plus 4 over z squared is 4 times z squared plus 1 over z squared plus 6, because the z squared and the 1 over the z squared cancels. Z to the 4 plus 1 over z to the 4 is 2 cos 4 theta. Using the above equation, there it is. Z squared plus 1 over z squared is 2 cos 2 theta. 4 times 2 is 8. Cos 2 theta plus 6. This is all 16 times cos to the 4 theta. So if I divide both sides by 16, I get 1 over 8. I've cancelled the 2, plus 4 cos 2 theta plus 3. So there is cos 4 theta in terms of cos theta, cos 2 theta, cos 3 theta, etc. Notice this is a very different technique to the one that we did in the previous video. If you use the wrong technique in the wrong place, you will give yourself a much longer problem to solve. There is a small difference when we look at sine to the power 5. In this case, the preliminary results that we're going to require from above are going to be z minus 1 over z is 2I sine theta, and also that z to the n minus 1 over z to the n is 2I sine n theta. Those are the results that we proved right back up here. Z minus 1 over z is 2I sine theta, and z to the n minus 1 over z to the n is 2I sine n theta. So I shall need those two this time. We're looking for sine to the power 5. So we take the first of these two equations, 2I sine theta to the power 5. That is z minus 1 over z to the power 5. Now we have Pascal's triangle 1, 5, 10, 10, 5, 1. Z to the 5 plus 5, z to the 4 minus 1 over z, plus 10, z cubed minus 1 over z squared, plus 10, z squared minus 1 over z cubed, plus 5, z minus 1 over z to the 4, plus minus 1 over z to the 5. Well, let's sort this out carefully. There are so many minus signs. This is z to the 5 minus 5z cubed plus 10. I put the squared in the wrong place. It should have been up there. Plus 10 times z, because the minus squared goes, and z cubed over z squared is just z. In the next one, we have minus cubed, z cubed on the bottom, z squared on the top. So that is minus 10 over z. In the next one, we've got minus to the power 4. So that's plus. Z over z to the 4 is z cubed on the bottom. So that is plus 5 over z cubed. And the last one is plus 1 over z to the 5. Okay, let's pick out what goes nicely together. Sorry, I have gone wrong here. Minus to the power 5 is minus. So there we have z to the 5 minus 1 over z to the 5. That's quite useful. Minus 5, I'm going to write minus 5z cubed, so I can put z cubed in. I've got plus 5 over z cubed. Because of the minus outside, I can write minus here. So that does give me plus 5 over z cubed. This one's a bit easier to see, plus 10 times z minus 10 times 1 over z. Okay, what have we got? The top line right up here tells us that we are dealing with 2I sine theta to the 5. 2 to the 5 is 32. I to the 5 is I, and sine to the 5. So we have 32I sine to the power 5 theta. The first one here is 2I sine 5 theta. The next one is 2, so that's 10I sine 3 theta. And the last one is 2, so that's 20I sine theta. Divide both sides by I and it disappears, which is rather nice. Divide both sides by 32 and we get 1 over 16 sine 5 theta minus 5 over 16 sine 3 theta plus 5 over 8. That doesn't look like a very good 8 sine theta. So this is a different, in a small way, to the previous one with cos, but it's exactly the same principle. This time we had to use the z minus 1 over z preliminaries. In the previous one, we needed these two, and you will do some where perhaps you might need this to start with, and the one with a minus in for the second. So you must just be aware of what's going on.